Now we're next going to take a look at a third method for solving quadratic equations, and that will be a method called completing the square. Now in this method we will be given an x squared term and an x term, and we will need to decide what constant to add to those terms to create a perfect square trinomial. And you remember that a perfect square trinomial can be factored into the square of a binomial. So we're going to look at a geometric justification for what constant term we need to add in the case where we have x squared plus 2bx. And this will be then a general approach that can be applied to completing the square for any situation we encounter from this point on. Now in the diagram below you can see that there's a big square, each of whose side is x, and I think you would agree with me that the area of this big square would be x squared. Now on top of this square we have a rectangle where the length is x and the width is b, and I think you would agree with me here that the area of this rectangle is b times x. And you see another rectangle to the right of the big square, each of whose dimensions is also b and x, so the area of this rectangle will be b times x. So what we have then for the areas of the square and the two rectangles, we have then, adding them together, we have x squared plus bx plus bx, and then simplifying we have x squared plus 2bx. Now I'd like you to think a moment, what is it we have to add to this figure below to make it a square? Now if you look in the upper right hand corner there, we need to draw a couple of extra lines there that will turn the entire figure into a square. Now you can see that the left hand side of the figure is x plus b. On the right hand side we have this dimension being x, so it seems reasonable then we're going to add a b to the top of that to make this figure into a square. So let me stop and do that now. Now you can see what we needed to do to make one big square was to add the two line segments in blue, each of whose length is b. So I think you'd agree now that we have the one big square where the length is x plus b and the width is x plus b. So now if we were to take a look at the area of this little square that we've added on, and if we add that area to the x squared plus 2bx down below here, I think you'd agree that that would give us one representation for the area of the entire figure. So, going back again, what we needed to do was to add that little square, whose area is b squared, to the x squared plus 2bx to complete the square. So I'm going to put that term right there. Now let's look at the big square in the figure below again, and let's find another representation now for the area of that big square. You'll agree, I trust, that the width of the square is x plus b and the length of the square is x plus b, and you know that the area of a square is side squared, so we could then write that the area of that big square is x plus b then quantity squared. So if you now put all the pieces together there, you can see that by adding b squared to the x squared plus 2bx, it factors into the square of a binomial, so then we have created a perfect square trinomial. And so I hope this geometric justification will give you some understanding of why it is we need to add the b squared to make it a perfect square trinomial. Now the algebraic approach for completing the square is to do the following. So let me come down here below and rewrite those first two terms again. So we have x squared plus 2bx plus some constant to complete the square. So what we'll do in a general sense then is always to take 1/2 the coefficient of the x term. So in this case it would be 1/2 of 2b, which simplifies to b. And then we square that result, and that's what we add to complete the square. That will then factor into the square of a binomial, so in this case it would be x plus b quantity squared. Now we'll reinforce this idea a bit later, but it's always important before you complete the square that the coefficient of the x squared term is 1.